Example, use the z-table to solve. On the basis of U.S. Bureau of the Census Statistics, the ages of women who bore a child in 2011 were roughly normally distributed, with a mean of 27.5 years old and a standard deviation of 6 years. At Mayberry Community Hospital, 526 babies were born in 2011. Approximately how many of their mothers were between 30 and 35 years old? To use the z-table, we'll need to use the z formula, data item minus mean divided by standard deviation. And this time we're going to need to use that formula twice because the question refers to two different data items, 30 and 35 years old. We want the number of mothers between those two items, so we'll need to find a z-score for each of them. Let's start with the z-score for 35 years old. So data item 35. The mean is 27.5, and the standard deviation is 6. Filling in the numbers from the problem, we get 35 minus 27.5 divided by 6, and subtracting on the top gives us 7.5 divided by 6. Dividing on a calculator, we get exactly 1.25. So we don't have to round that at this point because it did come out exactly 1.25, but let's look at the table. I'm looking for a z-score of 1.25, and that is not on the table. It's in this area, but since it's not there, I'll need to go to my guidelines. And the guidelines are to round it to decimal places. We didn't need to do that, but now we're supposed to find the z-score on the table that's closest to our answer. Now we're in a quandary because 1.25 is exactly halfway between 1.2 and 1.3. So it's kind of a toss-up, but let's go ahead and use regular math rounding rules, which would be if we have to round to one of these, if the second number is 5 or more, it goes up, and so we would use the 1.3. So for a z-score of 1.25, we're choosing a z-score of 1.3 on the table, and copying that line from the table gives us a percentile of 90.32 for our first z-score. Now we need to do a similar calculation for the other data item, which is 30. So we're mostly using the same numbers, but instead of data item 35, we're going to do another calculation now with the data item of 30. We'll find the z-score for 30, which is 30 minus 27.5 divided by 6. Subtracting the numerator, we get 2.5 divided by 6. And dividing that on a calculator gives us 0.4166666 repeating. Using our rounding guidelines, we'll need to round the z-score to 2 decimal places, and that would give us 0.42. We need to find the z-score on the table that is closest to 0.42. Our two candidates would either be 0.40 or 0.45. 0.42 would be closer to 0.40, so we're going to choose this line at the table and copy that onto our paper. Z-score 0.40, percentile 65.54. The question is asking us the percent. Actually, it'll eventually be how many, but we first have to answer the percent of mothers between 30 and 35 years old. So we're going to need to take these two percentile answers that we got from the table and subtract them. We'll take 90.32% minus 65.54%, and that gives us 24.78%. Final rounding guideline says to round that final percent answer to the nearest whole number. So we'll round that percent answer to 25%. Now if the question asked us for the percent of mothers, that would be the answer, 25%. But this time they asked us how many questions, meaning out of the total number they gave us, 526 babies born in that hospital, how many of them would, many of those mothers would be between 30 and 35 years old. So the answer will be that it's 25% of the 526 babies total. So that's the calculation we'll need to do, 25% times 526. We have to do that in decimal form, so we'll have to change the 25%, move the decimal point 2 places to the left, and make it 0.25 times 526. And doing that calculation on a calculator, we get an answer of 131.5. So to give that as a number of people, how many are their mothers, we'll also round that to the nearest whole number. Using regular rounding rules, since this number is 5 or greater, we'll round up to 132 mothers. And that would be our final answer, about 132 mothers.